Okay, hello there, grade 11s. I am just going to take you through a couple of examples here. And both of these triangles that I'm going to work through will be non-right triangles, and they will both require the sine law they will both require the cosine law before I will use the sine law on them as well. That way you just can see me sort of work through everything that we've done. Okay, so first of all, we have a triangle here, and the first thing you're going to need to be able to do in this unit is to recognize whether or not it's a right triangle, and we don't see a 90-degree angle. We don't see a little box, so that means that it is not a 90-degree triangle. So it's a non-right triangle, which means we're either going to use the sine law or the cosine law. Now, one of the conditions of the sine law is that we have an angle and a side that is corresponding. We can see that we don't have this side, so sine law is going to be impossible for us, and therefore in order to start on this, the only option we have is the cosine law, and that's because we have two sides and we have the angle between them, and that is one of the conditions of the cosine law. Now I'm going to write out the cosine law for this specific triangle here, and of course the side that we're going to be finding is little q. So q squared is equal to the sum of the other two sides squared, so r squared plus s squared minus 2 times r times s times cos of angle q. So it goes with this q, and there it is, big Q, and it's cos q. Okay, so now I'm going to go ahead and I'm going to actually plug the values in. So q squared equals r squared is going to be 11.4 squared plus 8.5 squared minus 2 times 11.4 times 8.5 multiplied by cos of 48 degrees. Now, if you remember what we were doing in class the other day, you'll remember that we're going to do these two together, and then we're going to do all of this together. So 2 times 11.4 times 8.5 times cos 48. And we're going to reduce those, and after we've done that, we will take this and subtract this from it. So I'm going to pause the video and I'm just going to use my calculator, and when I come back I will have the numbers filled in for you. So q squared equals, and I get 202.21, and from that I will be subtracting. So from that I will be subtracting, and I got 129.68. And if any of you remember this example from the other day, it probably seems a little bit familiar, and that's fine. So now I'm going to go ahead and I'm just going to subtract those two numbers, and I get that q squared equals 72.53. And of course, you probably remember that the common mistake from here is to say that side q is 72.53. But if you look at the other options, at the other sides, pardon me, you'll see that that doesn't really make sense. So of course, we have to take the square root of it, and we will get that q is equal to the square root of 72.53, which is going to be 8.5. So q equals 8.5 meters. And some of you probably remember this now because you remember finding that this side is exactly the same. And I remember you getting frustrated because it doesn't look like this is like it's the same, and that's fine. These diagrams are often not to scale, so that's totally okay. So at this point, I'm going to replace this here with 8.5 meters. And what I hope that you pick up on is that once I've done that, I now have, and here's Nick's little method here, I have a matching angle and side. And as soon as I have a matching angle and side, I am able to use the sine law. So from here, I'm going to use the sine law, and I'm just going to go ahead and I'm going to find angle R, and then I'll find angle S through subtraction. So I'm going to set up the sine law for angles. So I put sine R on top, and I divide by the length of side R, and that is equal to sine of Q over Q. I always use this one because it's the only one I have that's complete, and hopefully you remember that you need to have a complete ratio. So sine R divided by 11.4, and that's R, equals sine q. Well, q is 48 degrees. And I divide that by the length of q, which we just found to be 8.5. And all that's left from here is to isolate sine r. So that means I have to get rid of this 11.4. And a lot of you are starting to realize that you can just bring it up and across and multiply. If you don't like that, multiply on both sides by 11.4. It crosses out and it will just turn up over on this side. So it's the same thing as just bringing it up and over. So I'm going to go ahead and calculate that. So I have 11.4. I multiply it by sine 48. I hit equals on my calculator. I divide it by 8.5. And I get that sine of r, so I don't have r yet, so sine of r equals 0.9967. And from here, of course, r equals inverse sine, or sine negative 1, as many of us say, of 0.9967. And on my calculator, I hit shift sine of my answer, and I get that angle r equals 85 degrees. And from here, we have one more angle to find, and that's angle S. So angle S equals 180 degrees. That's what's in a triangle altogether. We subtract 48 degrees. That's angle Q. And we also subtract angle R, which is 85 degrees. And if we do that, we get that angle S, pardon me, is 47 degrees. And then you can go ahead and sum everything up, say that Q equals blah, R equals, S equals, angle Q equals, angle R equals, and angle S equals. And ideally, you would make a little summary of that at the end so that someone could look and say, all right, there's all the information, and it's easy for me to see what each side of the triangle and what each angle of the triangle is. Okay, so that's it for this example.